The universe functions as an immaculate mathematical compiler, instantly translating raw code into the solid physical landscape we perceive. Understanding this system requires abandoning the model of time as a fourth spatial dimension. Time is strictly the processing sequence of a hardware clock, operating at a master cycle of 23.67 MHz. The foundational database for this process is the Adelic, a static archive containing all past, present, and future data. Without an active observer to read this database, reality remains unrendered and inert. Human experience is the localized frame-by-frame rendering of this abstract database being continuously decompressed. The J unit acts as the observer transceiver, functioning as the read head moving through the universal database. This equation defines the exact mathematical coordinate of the observer node. The real part, 1/2, anchors the observer to the Riemann zeta critical line, providing a structural boundary preventing dissolution. The observer sweeps upward along the imaginary axis, metered by the hardware clock. During this sweep, the J unit intercepts zeta zeros within the data field. Every intercept triggers a Tate-Iwasawa-Mellin transform. This algorithm decompresses discrete p-adic code into the localized continuous geometry of space. The compilation pipeline begins with the serialization of physical states into L-function packets. Standardized packets are required to convert raw data into physical properties. These global L-functions act as the base currency of the compiler. This formula represents the data packet's internal structure. The gold matrix in the denominator is the Satake matrix payload, storing a particle's mass, spin, and charge. The padlock icon marks a cryptographic checksum. If corruption breaks unitarity, the system halts rendering. Physical particles are self-validating lines of arithmetic code, awaiting processing by the pipeline. Beyond data formatting, the system encounters computational hurdles during the rendering process. Physical mass represents computational viscosity, a drag on the processing speed of the system. Positive geometric curvature forces the master clock to dedicate more cycles to process the bundle shift, generating a measurable latency. A second hurdle involves translating data between incompatible force spaces, such as moving a packet from electromagnetism to the strong force. The universe utilizes Langlands functoriality as a universal API to execute these translations. The warped grid beneath the API reveals the nature of gravity. It is the computational footprint and routing latency generated by this translation process. Physical weight and gravitational attraction are simply the user interface experiences of a processor managing a heavy computational load. Processing microscopic data can generate cascading mathematical infinities that threaten to crash the rendering sequence. This jagged red noise represents infinite microscale algebraic data. The Grothendieck-Riemann-Roch theorem acts as a crash prevention protocol to neutralize it. The equation multiplies the microscale chaos against smooth macroscale spatial geometry. This operation results in destructive interference, where the anomalies subtract out to zero. If metric volume expands too rapidly, the Gillet-Solly analytic torsion equation acts as a brake. Its negative exponent forces the output to plummet, compressing the metric volume. Reality remains stable because algebraic geometry algorithms continuously run in the background to choke infinite loops. All simultaneous operations, data packing, viscosity throttling, and API routing, converge into a single requirement. The entire compilation pipeline must satisfy an overarching mathematical mandate. This mandate is expressed in the Adelic product formula. The net arithmetic variance of compiled reality must equal exactly 1.0. When the equation balances, the geometry stabilizes and the frame renders. The universe computes the exact value of 1.0 23 million times a second.